심사위원 분들 준비되시면은 바로 시작하도록 하겠습니다.
시작하시면 될 것 같습니다. 시작할게요.
네. 우선은 지금 먼저 참고로 지금 영상이 지금 녹화되고 있고, 그리고 두 번째로는 지금 영어로 발표를 해야 돼서 부족한 영어 실력이지만 영어로 발표를 좀 진행을 하도록 하겠습니다.
전체를 영어로 해야 되고요.
실은 5분만 하면 되긴 하는데
편한데.
네, 하다가 안 되겠다 싶으면 바로 한글로 바꾸겠습니다. 영어로 전축 진행을 최대한 해보는 걸로 한번 해보겠습니다. 네, 그럼 시작하겠습니다. Okay, then I'll start the presentation of my master thesis now. Hi, I'm Jiwon-seo and I'm here to present my thesis, opinion dynamics model of peer discussion. Let me start with the introduction section. As you know, student learning is a complex dynamics process, and it consists of various factors such as peers, teachers, textbooks, and etc. That is why social environments are important for student learning. And by social constructivism, knowledge is constructed through interaction with peers. As student learning is complicated and consists of various factors, as I said, it is hard to analyze. Therefore, this property inspires physicists to study them. Okay. To study this, physicists usually use two methods. The first one is massification, and the second thing is agent-based model. Okay. The first thing is the massification. Using the stochastic process, you can find the final state of the system given the initial conditions. For instance, one study found the specification derived from the massification to analyze the change in students' performance after and before discussions. However, these methods have difficulty in capturing individual properties. The next method is the agent-based model. Many social physics researchers use it. Okay. In this method, you define simple behaviors of agents and a system where agents are. After that, learn the system and watch the unexpected emergence property. For instance, one study made an agent-based model and revealed that students perform better in a heterogeneous group. In this figure, you can see the heterogeneous group line and homogeneous group line. And the heterogeneous group line is above the homogeneous group line. Okay. Even though previous studies reveal many educational principles using mathematical models, here is an interesting phenomenon that cannot be explained by the previous ones. That is, even without knowing the correct answer, students can reach the correct answer through discussion. But there is a critical condition that is very important condition, that is only if their initial answers are not identical. So let me explain this table, which is related with this sentence. All in the table, all means that all students in a group have the correct answer initially, and this group has nearly, you can see, nearly 100% chance of answering the correct answer through discussion. But all x means that all students don't know the correct answer initially, but this group has about a 30% chance of getting the correct answer after discussion, even though they don't know the correct answer initially. But what is important is the diversity of initial answers. You can see the difference in the light table. Okay, the case of all answers are the same. Okay, the below one. If all answers are the same, then it leads to no correct answer. But the case of all answers are different, then it leads to about a 40% chance of getting the correct answer. So with the research data, we hypothesize that opinion diversity is a crucial factor for improving group performance. So considering this, we made our own agent-based model to analyze the research data I just mentioned like before. Okay, here are our model's mechanisms. Firstly, diversity of opinions helps the group to find the correct answer. That is relative to egoistic theory, which is relative to social constructivism, as I mentioned before. Okay. Secondly, students' opinions are more influenced by others' opinions that resemble theirs. The last thing is students' memories of specific topics influence the possibility of revising their opinions. To recap, we made our model with this hypothesis and mechanisms. Okay, then let me move on to the model section. In this model, group members collaboratively discuss the problem, which means this study is not about opinion polarization, like dispute. Here are the model's assumptions. Okay, the first one is before forming a group, students initially solve a given problem individually. Secondly, all students have the same power of opinion. Thus, it means it does not allow someone to have a powerful or less powerful opinion. Okay, let's move on. In our model, students' opinions or answers are represented as the unit vector on a unit sphere. That means it is a three-dimensional vector. Okay, and the G component of the vector or opinion indicates the performance or score. The reason for using a unit sphere is to represent that there are various opinions with the same performance or score. In this study, we categorize the group types as NH, EH, and SH. NH means better performance group, which is sampled in northern hemisphere, and EH is sampled in eastern hemisphere, and SH is sampled in southern hemisphere. Okay. So the highest performance you can see the highest performance in SH group and the lowest performance in SH group. Okay, now I'm going to explain how students interact with each other in a group. First, let's look at the definition of group influenced opinion. This yellow term indicates the influence of the J student on the I student. If two students have the same opinion, then their influence enlarges. It means if two have the same opinion, then the scalar term became 1. That value is the maximum value. Okay, but however, if two have the exact opposite opinions, this term diminishes. That means that scalar term becomes 0. The next term stands for the scaffolding effect of the group on the I student. This effect grows as the group size and opinion diversity go up. This effect is similar to the external magnetic field in the paramagnetic Ising model. And this effect leads group influenced opinion to the correct answer. Herein, the term n to the power of alpha comes from social impact theory. This theory is that the additional social impact is diminishing with the increasing size of people. Now I'm going to tell you why the additional social impact should be diminishing. For example, imagine that you sing in front of people, in public. If the size of the audience changed from 1 to 10, then you feel very nervous. You might become very nervous. But with the change from 100 to 110, that change might not impress you that much because there are already many people in there. In our study, measuring opinion diversity is important. We measure opinion diversity by adding up the increasing function of opinion differences. At this moment, we set the beta as 0.5. Okay, you can see because if the beta is larger than 1, it contradicts our assumptions. You can see that as set the beta equals 0 to 0.5, the system is more sensitive to small opinion differences. Okay. Now I'm explaining some quantities that are needed for explaining the mechanism of change in individual opinion. At first, we define the memory vector as I, which represents the cumulative student's opinion for duration bt. We name T as the memory horizon or memory capacity. You can see how the memory vector is calculated with this picture. Okay, if you add up these all as vector, then you can get I vector. That is memory vector. Okay, if the opinion directs the same constantly, it means that there is no opinion change at all, and he or she might tend to maintain their opinion, which signifies that their initial or insistence on memory is large. That kind of value is measured and symbolized as the M. Okay, moreover, we define the big zeta, which quantifies the difference between individual memory and group opinion. If the difference is small, the value becomes 0, or if not, the value becomes large. Okay, this is the last part of the model section. This is about the time evolution of opinion. Students' opinion changes to the group influence opinion with probability pi, or maintains with 1 minus pi. Okay, pi is the formula for m and big zeta. Here are two examples of it. Okay, if m is large, pi decreases, indicating that inertia m hinders opinion change. And if big zeta is large, pi also decreases, indicating that a big difference between individual memory and individual opinion and group opinion hinders opinion change. This is typo, sorry. Okay, this flow chart is about helping you understand. Please note that. Okay, now I'm going to talk about my model's features. First, these figures show the temporal behavior of group performance and opinion diversity. In this case, we ran our model given the conditions mentioned in the red line below. As you can see, we ran it up to 100 iteration times, TF. Okay, you can see the very trivial results from this. That is, as time goes by, opinions tend to align toward the correct answer, regardless of the group time. It indicates that students perform better through group discussion. You can also find that all group members achieve the consensus state, indicating that opinion diversity vanishes. Okay. However, in our model, there are several parameters about time, such as TF and big T. First, I'm going to tell you what happens with varying big T. During this subsection, we only deal with the SH group type, the loyalty performance group, because this type showed noticeable changes. As shown in this plot, memory horizon big T affects the temporal behavior of both quantities. Oh, sorry. In these figures, you can find that as big T goes up, the slope, this slope or the temporal change in both quantities becomes smooth. Also, you can find that final group performance is the highest with the moderate value of big T, not the small or big value. Let me show you another figure again. This figure shows the final quantities for various big T. The final group performance is the high score about big T equals 20. But in that case, the value of B is the opinion diversity. Okay. Anyway, the value of B is not 0. That is, consensus hasn't happened yet. But we focus on the consensus state in this study. Therefore, we focus on the point BT equals 10. However, there is no solid reason to choose the iteration time TF to be 100 and the memory horizon to be BT to be 10. So it is necessary to check the consistency of temporal behavior regardless of choosing time relative parameters. To do this, we use the scaling behavior. The scaling variable T of BT and set TF of BT equals 10. We found that the temporal behaviors are similar for various choices of parameters with given the condition of TF of BT equals 10. So now on, we set TF equals 100 and BT equals 10. Because we thought that 2B TF is not suitable for explaining near educational situations. This is the interesting point of the research. This is about the effect of group size on the final group performance. So far, we set the group size as 4, but these results are from 2 to 10. The final group performance in NH and EH groups, I mean the yellow line and green line. Okay, in NH and EH group times doesn't seem like being affected by group size significantly, but in the red line you can see the red line. But in SH types, group size affects final group performance a lot. You can see the peak in the red line. And this indicates that both too small group and too big group size are not good. But it seems like a group size of 3 to 4 is optimal for group discussion. This is the last part of the leisure section. Figure A is the heat map that shows the final group performance given the multiple choice initial conditions. You can see the same result but as line graphs in figures B and C. Firstly, as shown in figure B, for a fixed value of the initial opinion diversity, the final group performance increases almost linearly with the initial group performance. However, in figure C, you can see different results. That is, the final group performance increases abruptly in this point, or when the initial opinion diversity is sufficiently large. We thus conclude, that is very important, we thus conclude that forming groups with diverse opinions is important for the group to approach the correct answer. Okay, now it's time to summarize and discuss my study. We modeled the opinion dynamics of peer discussion and hypothesized that opinion diversity within a group results in improved group performance. Within our group, we found 3 main results. First one is group performance is enhanced when initial opinions are diverse. Second, memory horizon influence group performance and consensus speed. The last one is small group size 3 to 4 is beneficial for better group performance. Moreover, with our model, we can explain the educational data that all the long initial answers make the correct answer. Furthermore, we can explain other well-known educational phenomena such as the optimal group size for group discussion and memory effects in learning. However, there are some unsolved problems. It is needed to study the mechanism of the scaffolding effect. Because in this study, we just merely verify the existence of scaffolding, not studying each mechanism. And moreover, it might be interesting to study our model in our other networks. We ran our model in small fully connected networks, but you can use and modify our model to simulate other social phenomena in various networks. Furthermore, I found one interesting research that is about opinion dynamics using agents formed by LLM, a large language model. So in the future, I'm starting by combining this study and LLM. Okay, thank you for listening to my presentation.
뭐 계속 녹화해야 되는 아니면